Hello guys and welcome back to the channel. Today we're going to be going through another maths worksheet aimed at those students that are targeting a grade 6 to 9 in GCSE Maths. The first question asks us to solve the equation 4x plus 7 is equal to 31. So by solving this equation, they want us to find the value of x, or x equals something. In order to do that, we can subtract 7 from both sides, which would give us 4x equals 24. But we don't want 4x, we want x on its own. So if we divide both sides by 4, we just get x equals 6, and that is how I solve this question. Question 2 asks us to expand and simplify x minus 4x plus 6. I use the FOIL method: first terms, outside terms, inside terms, and last terms. So if you do first terms, we'd get x squared. Outside terms would give us plus 6x. Inside terms would give us minus 4x. And last terms would give us minus 24. 6x and 4x and minus 4x, sorry, are both coefficients of x. So we can just add them together, which would give us x squared plus 2x minus 24. And that is how you expand and simplify this equation. Question 3 asks us to factorize completely x squared minus 9x plus 20 equals 0. So what we want to do is, in our two brackets, the two numbers that are on the sides should add up to give us this minus 9 and multiply to give us 20. And because we have x squared at the beginning, we know that our first two terms will just be x. Then we need to see which numbers add up to give us minus 9 and multiply to give us 20. Those numbers are minus 4 and minus 5. If you add them, you get minus 9, and if you multiply them, you get 20. And then this gives us x minus 4 and x minus 5. That is how you complete this question. Question 4 asks us to solve x squared equals 64. And because we have x squared and we want x on its own, we'll do the opposite of squaring a number to both sides, which would be square rooting them both, which would give us the square root of x squared is equal to the square root of 64. The square root of x squared is just x, but the square root of 64 is not just 8, it can also be minus 8, because minus 8 multiplied by minus 8 still gives us 64. So you can say x equals to plus or minus 8, and that is how you answer this question. Question 6 asks us to write 0.00089 in standard form. So remember, for standard form, our first number should be between 1 and 9.9. So in order to do this to this number, we'd have to move the decimal place across, and every time you move it one column, it's the same as multiplying it by 10. So once, 2 times, 3 times, 4 times, which would give us 8.9 times something, and 8.9 is between these two numbers, so we know we can use this. And because we've moved it 1, 2, 3, 4 times, we can say this is 8.9 times 10 to the power of 4, because you've multiplied it by 10 4 times, and that's how you do this question. Question 7 tells us a triangle has sides 9 centimeters, 12 centimeters, and 15 centimeters, and asks us to prove that it is a right angled triangle. So the way we can do this is, if a triangle is right angled, it will follow a squared plus b squared equals c squared, and c squared being the hypotenuse. So that would be 15 centimeters because that's our longest length. So if this is a right angled triangle, then a squared plus b squared should equal 15 squared. And obviously it doesn't matter if you do a as 9 or a is 12, because we're just adding them anyways. So let's say a is 9 and b is 12. So we'd have 9 squared plus 12 squared should equal 15 squared if this is a right angled triangle. So 9 squared is 81 and 12 squared is 144. If we add these together, we could see that 4 plus 1 is 5, this is 12, add 1 to the next column, 2, 2, 5, and so we get 81 plus 144 equals 225. If this is the same as 15 squared, we know that this is a right angle triangle. If we did multiply 15 by 15, we'd get 225. You can do that on your calculator if you need to. So then we can say that a squared plus b squared equals c squared, therefore right angled triangle. And that is how you do this question. Question 8 asks us to rearrange the formula y equals 5x minus 2 to make x the subject. So what that means is we want x on its own is equal to something. So let's start by adding 2 to both sides, and we get y plus 2 is equal to 5x. So this is a good start, but we want x on its own, not 5x. So if you want to get rid of this 5, we'll have to divide both sides by 5. So we'd get y plus 2 all divided by 5 equals x, and that is how you make x the subject of this equation. Question 9 asks us to solve the simultaneous equations x plus 2y equals 12 and 3x minus y equals 5. So with simultaneous equations, you'd want to eliminate either x or y, and then we'd see what the other value is. So here we've not got two matching or two things that are the same, like 2y and 2y or 2y and negative 2y. So we'll have to multiply everything in this by 2, so we'd have negative 2y here, and then the y's could cancel out. So if you multiplied everything here by 2, we'd get 6x minus 2y equals 10. And our top equation, we could leave it the same because we've already got 2y. We'd have x plus 2y equals 12. And if we want these y's to give us 0, we'd have to add them together. 2 plus minus 2y would give us 0y, which would effectively be cancelling it out. So we'd add these and we'd get 7x and 0y equals 22. So then x equals 22 over 7. And if you wanted to work out y, we could just substitute this into either of our equations. So we could say, if we choose the first one, we'd have 22 over 7 plus 2y equals 12. We could do this on a calculator, or we could just try and work it out like I'll do. So we can see that 22 over 7 plus 2y equals 12. To make it easier for us, we can just say that this 12 is the same as 84 over 7, because we just multiply top and bottom by 7. 12 is the same as 12 over 1. Multiply them both by 7 to give us 84 over 7, so we can just subtract easier. Minus 22 over 7 is equal to 2y. So we'd have 2y is equal to 62 over 7. So then y is equal to 31 over 7. And that is how you complete this simultaneous equations question. Question 10 asks us to find the nth term of the sequence 6, 11, 16, 21, and then there's more numbers after that. But so the way we do this is we look at the difference from one term to the next, and this is a linear sequence. So we can see that each term is going up by 5. We're increasing by 5. So we know that our n, the number that comes before n, will be 5, because every time it increases by 5. So we'd have 5n as the first part of our term for the sequence. And if we write out what the 5n values are, it'd be 5, 10, 15, 20. And if we compare this to our numbers, which are 6, 11, 16, and 21, you can see that in each term, the difference is plus 1. You have to add 1 to get from 5n to what we want. So we can say that the nth term for our sequence is just 5n plus 1. And that is how you complete this question. Thank you guys for watching our video. We hope you found it useful. Leave a comment letting us know what types of videos you want us to make next.